So let's answer number 8. A right triangle whose apex is at -4, 5 and has a base on the line 4x minus y plus 5 equals 0. Find the coordinates of the two other vertices if the triangle is also an isosceles. Okay, so let's illustrate the given first. Okay, so we'll draw the Cartesian plane. Okay, and then let's locate the point -4, 5. So 1, 2, 3, 4 on the left, and then 1, 2, 3, 4, 5 above. Okay, so let's locate that point. It's around here. Okay, so this one is the point -4, 5. Okay, next is we're going to trace the graph of the line 4x minus y plus 5. Okay, so let's have a table 4x minus y plus 5 equals 0. Okay, x and y. Okay, so let's find its intercepts. So when when y is 0, x is negative 5/4 or negative 1.25. And when x is 0, y is equal to 5. Okay, so let's locate the points. So 0, 5. The y-intercept 0, 5 above here. Okay, and negative 1.25, 0 around here. Okay, and then let's trace the line. Okay, so this is the graph of the line. Let's label it 4x minus y plus 5 equals 0. Okay, now let's reread the problem. Okay, a right triangle whose apex is at -4, 5 and has a base on the line 4x minus y plus 5 equals 0. So let's illustrate the triangle. So if its apex is on this point -4, 5, then it must be one of the vertices of the triangle. So that we can name this one as our point A, and the base is on this line. So that means that from this, if the base is on this line, then this one is actually the other one side that is perpendicular to that base. So let's draw a line is perpendicular. Okay, perpendicular to the to this line. Okay, so this one will actually serve as our height as opposed to the base that is on this line. Okay, so let's label this point vertex here as point B. Now for the base, since it was not specified where will be the third point B, as long as it is on this line. So there are actually two possible locations for our C. First is above, right above here. So let's name this one as C1. And of course, down below here, so let's label this point here as C sub 2. Okay, so these are the two possible locations for our triangle. It would be above, pointing upwards or pointing downwards. Now, what is required? Okay, so this one is 90 degrees. Yeah, by the way. Okay, so what is required is to find the coordinates of the two other vertices. So in our required here, required is the coordinates for P, for C1, and for C2. Okay, so let's go to the solution. Okay, so for our solution, first we're going to find the equation of the line that passes through AB. Okay, so this side here. And then the plan is, once we get the equation, we solve for the intersection of the two lines, the given line 4x minus y plus 5 equals 0, and that line to get the coordinates of P. Okay, so let's do that. Okay, so how do we find the equation of this line? Okay, so the equation of the line, since it's perpendicular to 4x minus y plus 5, so the general equation of this line is x plus 4y plus c equals 0. Okay, so perpendicular, the general equation of perpendicular lines is, all you need to do is you just need to swap the numerical coefficients of x and y, and then you also change the sign. So from negative it's positive. Okay, now all we need to do is solve for c. So we need to substitute negative 4, 5 since it is supposed to be on this line. Okay, so you have negative 4 plus 4 times 5 plus c equals 0. So this becomes 20 minus 4, so that's 16, and then transpose, you get c equals negative 16. So the equation of this line, therefore, that passes through AB is x plus 4y minus 16 is equal to 0. Okay, so next thing that we're going to do is we need to find its intersection with the original line. So let's have a system of equations then with the given line 4x minus y, okay, plus 5 is equal to 0. Okay, so we're gonna do this using the elimination method. So let's multiply the second equation by 4. Okay, so let's eliminate the variable 1. So you have here 16x minus 4y plus 20 is equal to 0. Okay, then we're gonna add the two equations. So x plus 16x is 17x, while 4y minus 4y is 0, and then 20 minus 16 is equal to 4. So that's plus 4 equals to 0. Okay, so solving, therefore x is equivalent to negative 4 over 17. Okay, next up is solving for y. So we're going to substitute x to one of the equations. So we're gonna use the first equation. So you have negative 4 over 17, okay, plus 4y minus 16 is equal to 0. Okay, so let's have, okay, so negative, let's use negative 4 over 17, okay, negative 4 over 17 minus 16. Okay, so this one will actually give you 4y is equivalent to 276 over 17. Okay, so solving for y, therefore, okay, so y therefore is 69 over 17. So therefore the coordinates for b, therefore, is x is at negative 4 over 17, and the y coordinate is 69 over 17. Okay, so that's for the b. Now what about the coordinates for the c? Okay, so let's go back here. Okay, so for c, okay, what we need to do is to also draw a perpendicular line that passes through point C. Okay, so let's draw that line in particular. Okay, passing through C. Okay, okay. Now, there is another given information here that this triangle, or this right, aside from being a right triangle, this is also an isosceles triangle. So that means that whatever is the distance from A to B will also be the distance from B to C1 and B to C2. Okay, so let's just be clear about that. So we say that AB is equivalent to BC1 and it's also equal to BC2. Okay, so we need that. We need to be clear with that information so that we will be able to get the equation of these two lines. Okay, passes through here. Okay, so first is we're going to find out what's AB, what's the distance AB, and then let's compare it with BC1 and BC2. So since this is the point, this is point A and B is on the line, so we can use the distance formula between a point and a line. So let's solve. AB is equivalent to the absolute value of 4 times negative 4 minus 5 plus 5 all over square root of 4 squared plus 1 squared. So this one is equivalent to, so let's solve first. So this one will actually give you 16 square root of 17 over 17. So 16 square root of 17 over 17. Now let's find the distance now between this point here, B to C1. So that same distance, by the way, this the equation of these two lines is also the same, has the same coefficients as this one, since this one is this line here, AB, is also parallel to these two lines. So we're gonna use that fact, 16 square root of 17 over 17, to solve for the C of the these two lines. That is still currently unknown. So this one is equivalent to x. So we're gonna use again negative 4 plus 4 times 5 plus C all over square root of 4 squared plus 1 squared. So taking the absolute values of plus and minus, 16 square root of 17 over 17 is equivalent to square root of 17 times 16 plus C. So solving for C therefore is equivalent to negative 16 plus and minus 16. So there are two possible lines. The equations of these two lines are as follows. So first is x plus 4y minus 16 plus 16 equals 0, or that would be x plus 4y is equal to 0. And then the other one, of course, is equation 1. And the other one, of course, is x plus 4y minus 16 is equal to 0, or that's x plus 4y minus 32 is equal to 0. So that is equation number 2. So what we're gonna do is we're gonna solve the intersection between this line and, of course, the 4x minus y plus 5 equals 0. Same thing that we did here to get C1. And of course, for this one, we're gonna also solve the intersection for another value of C. So let's solve another system of equation. So you have your x plus 4y is equal to 0, and this one is 4x 4x minus y plus 5 equals 0. So I'm gonna use the same elimination method that we did with the first one. So you have here times 4. So you have here again 16x minus 4y plus 20 equals to 0. So let's solve again. So this one cancels out, this one is 17x plus 20 equals 0, or you get x therefore is equivalent to negative 20 over 17. Okay, next is we're gonna substitute again the x with the first equation. So you have negative 20 over 17 plus 4y is equal to 0, or y therefore is equivalent to 5 over 17. So the coordinates of the intersection is negative 20 over 17 and 5 over 17. Okay. But we don't know which one, which c is it. So let's try to solve first the third one. Okay, so let's write x plus 4y minus 32 equals to 0, and then 4x minus y plus 5, okay, equals to 0. Okay, so again, another elimination method. So here you have multiply it again by 4, so this is 16x minus 4y plus 20 equals to 0. Okay, so this one cancels out, so this one is again 17x, and then negative 32 plus 20 is negative 12 equals to 0. So x therefore is 12 over 17. Now let's substitute it to the second equation. So you have first equation rather. So you have 12 over 17 plus 4y, okay, minus 32 equals to 0. Okay, so 12 over 17 minus 32. This one will actually give you 4y is equivalent to 532 over 17. Y therefore is equivalent to, okay, 133 over 17. Okay. 133 over 17. So the coordinates of the intersection is 12 over 17 and 133 over 17. Okay, so judging from, let's check. Okay, so judging from the coordinates, okay, so C1 is probably on the first quadrant. So this one here, okay, is probably the C sub 1, since all of its coordinates are on positive, therefore it is on the first quadrant. And C sub 2 is probably on the second, looks like on the second quadrant, which corresponds to this one, a negative x and a positive y. So this one is C sub 2. So here is the final answer. C sub 1 is 12 over 17, 133 over 17, and C sub 2 is negative 20 over 17 and 5 over 17. So here are the three final answers. Okay, thank you.